Next speaker will not be available for questions, unfortunately, but I'm sure you'll enjoy the talk nevertheless. The next speaker is Samuel L. Montgomery Blinn. He's a software test architect at SAS Institute. The talk is about using implicit context to create rich behavior-driven keywords. Let's enjoy the talk.
Hello, and welcome to Using Implicit Context to Create Rich Behavior-Driven Keywords. I'm Samuel Montgomery Blinn. I work at SAS Institute on the Customer Intelligence product, and there I am a QE architect or software test architect, and I've been doing software test automation as a professional for 22 years, and it even goes back a little further to my senior project at Purdue. Test automation has been my passion for a very long time, and at SAS, we've been using Robot for quite a long time. We have thousands of tests just on my product, run many times a day in many environments. So huge fans of Robot, and I'm very happy to be giving a talk for the second RoboCon in a row, and I hope you all find it useful. I'll say hi here for a second as well. So, when I pull up a listing of the talk's agenda, hopefully this gives you a little bit of a hint. We're going to be doing some kind of gherkin behavior-driven design language fun here. Given I understand the technique of implicit context, when I apply that technique in creating my tests, then those tests are easier to write, read, and understand. So this overview of what we're going to talk about is kind of tongue-in-cheek, but it's got the given, when, then format. You might see some bold here, that technique and those tests. And that's kind of the theme of where we're going to go here, is we understand what we mean, that technique is the technique we just talked about, and those tests are the tests we just talked about. Computers sometimes aren't always the best at getting implicit context, but we're going to get there. But how do we get there from here? Well, we're starting at something that's basically incomprehensible to mere mortals. Even with Robot 5 and its more natural loops and blocks, good job team, a fairly straightforward test can look a little like forking Perl golf to stakeholders. We've got $signs and curly brackets and equal signs, and we have to have 2 or more spaces between these things. We call some keyword and another keyword, and there's some magic verification keyword that goes in the end with these mystery flags that kind of handle everything for us. And as we work on our area of expertise day after day, we have our test knowledge builds up. We know what these keywords do. We know what these flags are. And, maybe some developers who have really gotten into debugging and writing tests as well can start to understand these things, but we don't quite get the level of readability to the other stakeholders, like our project managers who want to know how things are going and how well the tests are reflecting what we're building. And beyond that, our product managers who are really wanting to know what we're building and how it's fulfilling the requirements and the features that our customers want. And if we showed this to a customer, they would have absolutely no idea what we're doing. So we don't show this level of testing to a customer. We like to have these nice given, when, then scenarios. That's what those scenarios are for. But BDD, this gherkin language, is not always a silver bullet. We often find ourselves hoisted with our own BDD. For API tests especially, and event-driven tests, BDD language can all too often become very unwieldy and repetitive. So given a new API request to /foo with priority 1, when a response for an API request to /foo is sent within the time limit for priority 1, then the success event log will include a record of a response to a request to /foo with priority 1. This is obviously a contrived example. Hopefully we don't have too many tests that look like this. But it's not too far from the truth if you're trying to write keywords in a more, coming from a functional background where you want every single keyword to have all the information it needs at one time. Because that actually makes the keyword implementation really easy. You say, okay, you testers, you want keywords. Here's a keyword. You just have to tell me every single thing about what you want this keyword to do every time you call it. That's not great. Testers don't like to do all that. I don't want to read all that. I don't want to maintain all that. In fact, these kinds of keywords will get worse and worse with more parameters. Say you wanted to have additional parameters to our API request, giving some IDs, giving some other timing issues, giving some maybe client types, and so on and so forth. These get worse and worse, or can devolve really into, I would prefer my own petard actually to be hoisted by, because we'll get the worst of both worlds. We'll get something like this. We'll get variables mixed in with our BDD. And sure, we didn't have to repeat /foo or priority 1 over and over again, but we have to, pass along this weird $ request.path. And then we have these nested objects as we get further on. And, yeah, we've had a few tests like this as kind of midpoint in our journey with Robot over the years. We try to get rid of them fairly soon because, again, as these get more complicated, it doesn't help the readability. It doesn't help us share these tests around. And testers don't like to write them. And the stakeholders don't want to read them. And so, in fact, now nobody is happy. We've got miserable testers. We've got miserable project managers. We don't have any success. These tests disappeared to a bucket and are never heard from again. What if we just tried plain language? Like that first slide of this presentation. What if we just tried plain language? What would that look like? Something like this. Given a new API request to /foo with priority 1, when a response to that request is sent within the prioritized time limit, then the success event log will include a record of that response. That seems pretty simple. Why didn't we just do that the first time? Because we implicitly understand the context here, that request means that a new API request that we just talked about, the literal line before, and that response is referring to a response to that request. Literally a line ago, computer, you got to be able to do this. I mean, keep up, right? So let's just have our keywords. Well, I got to get my ugly mug out of the way here. Let's just have our keywords also understand the context. Let's not get a full Turing complete NLP system going just yet. 5-10 years is about at least I want to be working. So, save those projects for another 5 to 10 years. I'll appreciate it. So let's start. Let's start with some basic implicit context. Keywords. So what might a BDD inline parameter keyword look like? A new request to $path with priority $priority. A request, construct API request. This is basically making, kind of simulating a call into your actual test infrastructure or your application. We're constructing these request objects with keywords that are something else's responsibility. And here's where we're setting this implicit language. We're setting a new test variable called that request. And kind of a convention that I've been really happy with the last couple of years is, even though this is a behavior-driven keyword, and we're very intentionally making it to use implicit context, it's still nice to just go ahead and return the most likely object. So in this case, it's this request object that we just created. This actually makes these keywords reusable as explicitly called keywords from different test cases and different projects. And it's just a nice thing to do for the next person who comes along and may want to use this keyword in a slightly different way and not worry about implicit variables like that request. They may just want to call and get an object. So we already have it. We might as well do it, so we return it. We'll stop talking about conventions like that for a little bit. Another BDD keyword we might have is a response to that request is sent within the prioritized time limit. So what would that look like? Well, we're going to process request. Again, that's a contrived call into our application logic or our deeper test libraries. And we're just going to say, hey, $sign that request. You better be there. And we'll store the response. And you know what? We'll go ahead and we'll set test variable that response for that response. And go ahead and return that response object. One quick note is I am following the recommended use of the escaped variable name here for these set test variable calls. And the third line of our previous slide of our simple test case, the success event log, will include a record of that response. So again, we just go ahead and call and say that response, that implicit object should be there. Let's just call again down into our application logic. And while we're in here, even though we haven't yet defined any reason to keep around that record for this record, why not? We're building a language here. Go ahead. We've got a record. We might as well say the next time someone says that record, we should refer to this record that we just had. And, again, also just return it. This is kind of good practice as you're building all these behavior-driven keywords. I don't like to have given, when, or then in front of them unless I really only want you to use it in that particular context. So that way you can have an and, you can take a given and make it a when, you can take a when and make it a then. And that gets even better as we get away from these kind of contrived, simple examples to the bigger language that we can really rapidly create. Again, we're going to stack up this implicit context. We just saw a simple one, that request. Now, what about that first request, right? So what if we had, when I make a first request with priority 1, and I make a second request with priority 2, and I want to say, now that first request should finish first. It's got a higher priority. Well, do I have to lay everything out again and go back to kind of the unwanted level of detail for my BDD keywords, or can I just go ahead and say that first request? Why not? How would that look? How would we keep track of that? Well, we'll take our previous keyword, a new API request, exactly the same. We call down into our application logic the same. We set our test variable of that request the same. But while we're here, let's check and see if we already have that first request. We're using this handy get variable value keyword that's a part of built-in, and say, okay, if we already had that first request, we'll just return that. Otherwise, this must be the first request. So a request becomes a first request. We set the variable, and we go ahead and, again, return the request that we just had. That's not too bad. But, okay, what if we also wanted that second record? Okay, so pretty soon we've got pretty ugly logic to also keep track. Hey, do we have a second request yet? Okay, push this first one up the stack. Okay, let's not do that, because then we're also going to be cutting and pasting, because I actually said record here, not request. So now we're going to have these different code blocks copied all over the place. That becomes a pretty horrendous code smell, one that still emanates from some of the programs that I've written over the years. And we're using this technique to clean up as we speak. But anyway, how about that second record, or that third request, or that last or next to last event? we're going to build a vocabulary here. And we're going to do that by pushing all of the logic around maintaining this context to a couple very simple, almost trivial keywords, helper keywords. So again, we have a new API request, BDD-style keyword that our testers can use. And the first line, unchanged, it's our actual call down into our application logic. We're going to call a method something like push implicit context request, and then that object. And again, just to be friendly to the next person who may want to call us a different way, return the A request. So what does this push implicit context look like? You got to give a context name, and that basically just means the noun. So these contexts that we're talking about, whether it's request, an object, an action, a user, a file, whatever it is, we're usually talking about that or the previous or that first noun. So the context name is just the noun. In this case, we have a pretty generic noun like request, not a really good one if your application has many different types of requests, which most of ours probably do. And the second argument is just the object you want to put into the context. So one of the cool features of Robot we're using here is the fact that variable names themselves can be partially composed of variable names. So we're going to set test variable of that underscore noun. So if we said request, we're going to have a new variable of that request. If we had said record, we would have that record. If we had sent event, we would have that event. And we're just storing that test variable for later on in the test case there. And we're also going to build up a stack. So this stack is going to be coming from, again, an implicit variable called, like, basically all of those nouns. So obviously not every noun gets a plural of an S. So we'll have weird things like sheeps or various other strange corners of the English language. But it's fine. It's just a variable name that no one's ever going to reference directly. So it's fine. It's fine. So we're going to get the variable value. Again, this is a really nice keyword here from built-in. If we already have our stack started, we'll return it. Otherwise, we're going to use the lovely syntactic sugar of @empty to start with an empty list. And we'll just append our new object to that list. And again, store that stack of those nouns with our updated list of those objects. And how are we going to use that? Here we go. This is not how I recommend you use it, but it's one way you could use it. So we know that we're using this convention of those underscore nouns, those requests, those records, those events, those messages, on and on. We know we have a stack or list of those. So the first one is always going to be at 0 because we keep appending to the end as we progress through the test. So the 0th one will be the first one. And we can say, hey, the first request exceeds a nice keyword that's really easily read and understood by every single person who looks at a test. We implement that by going into our implicit stack of requests, getting the first one, and then again calling down into our test or application logic that this request should succeed. The second request is ignored. Very similar. We just use indexed 1 because we like, we're computer scientists. We like 0 indexed arrays. Get over it. Second request is ignored. And this gets more fun is the last request results in an error because get from list looks a whole lot like a Python list indexing. If we pass -1, we get the last one. If we pass -2, we get the next to last one. So we can grab, these objects off of our implicit stack and call whatever we want with them. In this case, again, a kind of contrived request should result in error on this request object that we found. Okay. I don't usually use it that way at all. What I like to do is basically build the vocabulary up even bigger with more natural language looking keywords. And here we go. So if we want to have real flexibility, what we can do is something like this. We can basically say, hey, I want almost anything that our testers can come up with to just work. So if they want to have given, when, or then, the first, last, next to last request completes before the fourth, fifth request, that's fine. This kind of grabs this $ here and grabs this here. So if I said first, this becomes first. If I said next to last, this becomes the word next to last. And we're going to introduce a second, again, almost trivial helper method. And it's really, that's the only two methods that we have in our little helper library that we use to manage implicit context. Again, we got to pass the kind of noun that it is that we want. And so we're going to say get implicit context request first, get implicit context request next to last. And then again, this is simulating calling down to our application logic. Request should succeed before request. Some first request and this next to last request. So what we can do is build up a vocabulary so that we can introduce a request with a certain priority, a next request with a lower priority, and say, hey, the first request should succeed before the second request. And boom, that's all the test has to say. So what does that look like? How do we implement get implicit context? One is a really simple dictionary map of when I say first or second or last or next to last, what actual integer index do I want out of my list? So really trivial. There's probably already 100 Python packages that have this defined, but when you're defining it for yourself, you can pick as many as you want. In this case, I said basically, if you've got more than 6 objects in this test, you deserve to make a pull request. And we got our last -1, next to last -2. And our get implicit context method looks pretty much like this. Again, your noun type and then your kind of human friendly index of first, next to last, etc. We just get from the dictionary this guy, and we get our integer out of that, and we get the list those nouns, so those requests, those events, etc., and the actual index we wanted, and we just return it. So you can make a whole bunch of error checking logic, but I'll show you later why we don't bother, because we like the error messages pretty much just fine. So let's go ahead. Let's take a look. Let's play. I put together a small GitHub repository for this talk. Some real quick notes. I'm using Robot 413. I'll go ahead and turn my picture back on now that I'm not trying to squeeze everything into a tiny little window now. Using a Robot 413. And if you think we're far behind, up until about a month ago, we were still using Robot 3.2. And up until about 6 months ago, we were still using Robot 3.1. So we are storming ahead now. And the files that I put up there are happily accepted by RoboCop version 1.12. I haven't gone up to RoboCop 2 yet. I will soon. I'm getting more and more happy with using RoboCop to make sure no one can check in code that's terrible. So anyway, let's check this out. Let's check out what we've got here. All right. So here's our little GitHub repo. It's only got a few files in here. One is, what actually is a copy of our implicit context library.resource. So again, here you see we've defined our kind of translation table from our human-friendly ways to reference something out of our context, the first object, the next to last object, and made the values be what list index that will actually be in our stack. And here's the keywords, just as you literally just saw them a few slides ago, little shorter variable names. And one other feature is you can optionally set the scope. I think you should almost always use a test scope, but if you really want to use suite scope or global scope, you can. I don't recommend it. It's a good way to get into trouble and to break us being able to use PA bot with test level split, which we love. So, but it's there. Anyway, it's set test variable, etc. This is exactly what we just saw. So I'm not going to go over it anymore. But let's look at something more fun here. The actual tests that use this stuff and drive it. And I'm really at the edge of time here, so I'm going to kind of race to the end here. And I said that RoboCop is happy, but only because I told it to disable certain things in certain files. It doesn't like this non-camel case keyword like this, a new RoboTalk. So this is a little test case that shows how you might use this library in conjunction with your own BDD layer and your own application layer. So these tests actually run and they all pass. You know, the application that you can go and explore here is basically a mock database of RoboCon talks called RoboTalks. We can create them with titles, and we can say things like, given a new one, when that one is complete, then there is a scattering of applause. Given a new one and another new one, when the first one is complete, then there is a scattering of applause for that next to last RoboTalk, and the last RoboTalk has not yet received applause. And then, you know, going on to show you what the errors look like if you haven't properly set up your context before you try to use a keyword that wants that context. Again, you can do a whole bunch of hoops and add a bunch of error checking if you want, but so far we're pretty happy with the error messages that we get kind of just popping out of there. So you run all those tests and you get a nice little test suite, and you can kind of drill in to see what we're doing here. And you can see how these things execute. Here's that push implicit context being called. We're running set test variable for our object. And, you know, drill down and see and play. So I'll come back to the presentation now, and I'll say thank you so much. Hopefully this little tiny micro technique has been interesting to hear about, and I hope you find it as useful as we have. And I hope it really unleashes your testers and your developers and pleases your project managers and product managers and customers, because they'll have actually readable scenarios that are the actual scenarios that you implement for them. So cheers. I've been Samuel Montgomery Blinn from SAS Institute, and thank you to the whole Robot Framework team and the RoboCon team for having me back again this year. Thank you.